Hello, this is Mr. Buffington. We're going to look at parallel lines and transversals today. What is a parallel line? A parallel line are two lines on a single plane that do not intersect. They look like this typically. They'll run next to each other and never touch. No matter how far you extend them into infinity, they're not going to cross each other. All right? And they are on the same plane. We often call that coplanar lines that do not intersect. All right, so that's what parallel lines look like. A transversal is any line that intersects two other lines on the same plane. Specifically, what we're going to look at is a transversal that intersects parallel lines. So it's going to look like this. All right, so we're going to set up two parallel lines, and then we're going to draw a transversal across them and talk about all the different things that are created by all these angles that we see here. So how many angles are there when we look at the transversal and where it crossed these two parallel lines? When a transversal crosses two lines, you get 1, 2, 3, 4 angles there, and then 1, 2, 3, 4 more angles here. So you'll get 8 different angles. We're going to talk about the relationships between these 8 different angles, because there are some really neat things that happen with parallel lines and transversals. So let's go ahead and just get right into it. Alternate angles. When we talk about alternate angles, we're talking about angles on different sides of the transversal. So here's an example, 2 and 7. Remember, our transversal is this line that crosses over the two parallel lines. So our transversal, anything on opposite sides of the transversal are called alternate angles. All right, so you could also have this, like 2 and 5 are alternate angles because they're on opposite sides of the transversal. All right. We'll also talk about exterior and interior angles. Exterior angles are angles that are on the outside of the parallel lines. All right, I've represented that with these light blue shaded sections. All right, anything on the outside of the parallel lines are going to be called exterior angles. Anything on the inside of the parallel lines will be called interior angles. It seems pretty straightforward, but I just want to be clear of where the exterior, interior, and then also the alternate that we talked about. And so the next part then, of course, is to put these two ideas together. An alternate exterior angle are the two angles that are on different sides of the transversal, like 2 and 7, and they're on the outside of the parallel lines, the exterior of the parallel lines. Those are alternate exterior angles. The other example of alternate exterior angles is angle 1 and angle 8. They are on the different sides of the transversal, exterior or the outside of the parallel lines. The neat thing, property of alternate exterior angles is that they're congruent. They're the same measurement, and they look the same. Look, the measurement of angle 1, here it's definitely an acute angle, and you see measurement of angle 8, it looks the same, and they are the same. Alternate exterior angles are congruent. All right? So that's one property and one way that essentially if you know one of these 8 angles, you can tell what all the other 8 angles measurements are. And that's neat. And one of the ways you know that is because alternate exterior angles are congruent. All right. Now that we've talked about alternate exterior, where do you think the alternate interior angles might be? We see the word alternate, which means they have to be on different sides of this transversal. One will be on this side and one will be on this side. And we see the word interior, which means they'll be on the inside of the parallel lines. So one example of alternate interior angles is 4 and 5. Angle 4 and angle 5. The other example is angle 3 and angle 6. And just like alternate exterior angles, we know that alternate interior angles are also congruent. So angle 3 is equal to angle 6. Angle 4 is equal to angle 5 because they are alternate interior angles. Corresponding angles. And for me, what I like to do when I'm thinking about corresponding angles is I like to look at just one set of 4 angles at a time. So I look at this set of angles, and you could put a circle around it or a square around it or something just to say I'm looking at just this section, separate from the other ones. And then put a similar circle around that. And basically what corresponding angles means is if you're only looking at this circle and this circle, they're in the same exact place. Alright, so corresponding angles are angles 2 and 6. Can you see another set of corresponding angles? Perhaps you notice that 1 and 5 are corresponding angles. 3 and 7 are corresponding angles, and angle 4 and 8 are the last set of corresponding angles. So I'm going to represent them by color coding them here to show that these are the corresponding angles. Again, for me it's easiest to just put a circle around that. You can also color code it if that helps, and identify which angles are corresponding. Now, one property about corresponding angles, you may have already guessed, is that the corresponding angles are congruent. Alright? Angle 2 is the same measurement as angle 6. Angle 1 is the same measurement as angle 5. So corresponding angles are congruent. They have the same measurement. Alright. The next set of angles are called adjacent angles. And adjacent just means next to. So basically any two angles that are next to each other. 2 is next to angle 4. 2 is also next to angle 1. We could have highlighted 2 and 1. They're adjacent angles. 2 and 4 are adjacent angles. Here's another example. 5 and 6. Those are adjacent angles. 1 and 3 are adjacent angles. There's lots of sets of adjacent angles. And adjacent angles, if you look at this example in 7 and 8 here, you'll notice something, that angle 7 plus angle 8 gives you a straight line. So that means that adjacent angles, and you saw that with every case, angle 1 plus angle 2 gives you a straight line. Angle 2 plus angle 4 gives you a straight line. These angles are supplementary angles. In other words, they add up to be 180 degrees. All right? And that is the key for finding, like I said, if you're given one angle measurement, you can find all other 8 because you know that the adjacent angles equal 180 degrees. And they added them up. All right? The final type of angle that we're going to talk about are vertical angles. Vertical angles are another way of saying angles that are exactly opposite each other. All right, like angles 5 and 8 are a set of vertical angles. You pick out another set of vertical angles. Perhaps you said angles 6 and 7. Those ones are vertical angles. All right. Also, angle 2 and 3 are vertical. Angle 1 and 4 are also vertical angles. And vertical angles are congruent. So that is our lesson on parallel lines and transversals and some of the properties made by, or some of the properties of the angles that are created when you have a transversal cut across two parallel lines. If you enjoyed this lesson or found it helpful, you can go ahead and share it with your friends, share it with your math teacher, share it to anyone you'd like.